All right, 25. Find the number of terms in each sequence. Okay, now I admit right off the top here that this question right here is actually fairly difficult in most cases here. You're going to learn some stuff in Math 30 that will help you deal with this in general here. But there's going to be some certain things that happen in questions like this to make this a lot more accessible at the level that we're at right here. So I need to find out basically what the n value is for this last term here. Remember, for this first term, n is 1. For the second term, n is 2, n is 3. So I need to figure out what the n is for negative 192, and that will tell me how many terms there are in the sequence. So my first term is negative 6. My r value appears to be, well, the sign isn't changing. And to go from 6 to 12, I'm multiplying by 2. So now what I've got here is the last term is negative 192, and that is going to equal the first term times 2 to the n minus 1. Okay, so the very first thing I want to do here is isolate. Basically, I'm trying to solve for n here. Now, I'm not going to be able to do this super directly. Like I said, you'll see in Math 30 that there is a more direct way of handling this, but the first thing I'm going to do is divide by negative 6. That's going to get me 32 equals 2 to the n minus 1. Now, what makes it possible for us to solve it at this level is that the number that you're going to get on the opposite side of the equal sign here is going to be a power of 2. 32 is, and you play with it a little bit, and you'd see that that is going to be 2 to the 5th. So 2 to the 5 is equal to 2 to the n minus 1. Well, if you've got power equal to power, then that means, and the base is equal to the base here, then that means the exponents must be equal. So just by deduction here, I know 5 must equal n minus 1, which means n is equal to 6. That's the number of terms in that sequence.